Hello everyone, and welcome to another Leetcode video. So today we're looking at Vowels Game in a String, which was question 2 of Weekly Contest 407. So this question reads that Alice and Bob are playing a game on a string. So we're given the string S, and Alice and Bob will take turns playing the following game, and Alice is going to start first. So on Alice's turn, she has to remove any non-empty substring that contains an odd number of vowels. On Bob's turn, he has to remove a non-empty substring that contains an even number of vowels. So the first player who cannot do this will lose. So say, for example, Alice has to remove an odd number, but there are 0. That means she cannot make any moves because there's not an odd number of vowels. So they're also going to play optimally. And we'll talk about what this means later, but this is a very important hint in this problem. So we want to return true if Alice wins the game and false otherwise. And it just clarifies that our vowels are A, E, I, O, and U. So let's look at this example with the string Leetcoder. So we see the output is true, which means Alice wins the game. So how this happens is that Alice goes first, and she removes the longest string, which contains 3 vowels, which is this L to this O, right? And then this leaves just D, E, R. So then Bob goes second, and he can delete the underlined string in D, E, R, which contains 0 vowels, which is just D, right? And then E, R is left. So then Alice can play third. She can delete the whole string ER because it contains 1 vowel. So then Bob goes again, but the string is empty. So at this point, Bob cannot make any moves, so Alice wins the game. So let's look a bit closer at these examples and see how we can solve this. So when you look at these examples and think about what the problem is asking us to do, you might be thinking of some very complex algorithm that updates the string in place. So let's see what that might look like. So remember, Alice plays optimally, so basically she would want to find the longest string that has an odd number of vowels. So let's say we go all the way from L to O, and we delete this, right? So now we're left with DER, and as you saw in the example, Bob has to remove an even number, and 0 is even in this case. So here, we can remove this, we're left with ER, and then Alice can take this entire thing, so she'll win, right? So how would we actually simulate this happening? So we'd have to do something where we go to the string, we find the longest string that meets the criteria, then we have to cut the string, and it just becomes very complicated and a lot of time complexity because we have to basically go through the string each time. We have to update the string by slicing it, which is another O of N operation. So it's pretty slow, it's pretty cumbersome, it doesn't really make a ton of sense. So one thing we can do is just use logic. We don't need any fancy algorithm here, and this is kind of like a classic competitive programming problem where you just have to figure out the logic of how Bob or Alice can win. So let's look here. So in this case, we have an even number of vowels, right? And we know that Alice is going to win in this case when there's an even number of vowels. So let's see if there is an odd number, what would happen. So we go here. So we're just basically taking that E out. So what happens here? So this entire string has 3 vowels, right? And we know that Alice is going to play optimally, so she's going to take this entire string, right? So we know that if there's ever an odd number of vowels, then Alice will just win by default because she goes first. So we saw that when there's an even number, right, Alice can win because she'll take all but 1 of the vowels, and then Bob will be forced to just take a consonant, and then Alice will win. So if you follow that, Alice will win both when we have an even number and an odd number, right? So let's do that again. For an odd number, Alice will just take all the vowels by default and win on her first turn. What happens with an even number is that she will take all but 1, leaving an odd number, which Bob cannot take. So the next turn, she's going to take whatever's left and win. So whether we're odd or even, right, Alice is going to win. So is there any way that Bob can actually win? So the only way that Bob can ever win is if we start with a string that literally has 0 vowels. So for example, if we take this string here, we see that there's no vowels. So that means on Alice's first turn, she can't do anything with this string because there are 0 vowels. That is not an odd number, so she cannot remove anything. However, it then goes to Bob's turn, and remember, 0 is even, so he can take this entire string, and Bob can win, and we return false. So literally, there's no algorithm here. All we're doing is saying, if there's a vowel, we return true, otherwise false. So this is just O of n time complexity. We're just going through the string and checking if any vowel exists, which takes O of n time. So let's hop over to the code and see exactly how this works. It's very simple. So the first thing we do here is we just set up our set with all the vowels we're looking for. We're going to go through all the characters in the string we're given, and if any of these characters are vowels, we return true, because we know that if there is any instance of any vowel, Alice is going to win, and if there's not, we return false. So let's submit and make sure this works. And it does. So hopefully this is helpful. This is a pretty interesting one because there's really no algorithmic knowledge needed. It's just plain old thinking and logic. So hopefully this made sense, and thank you for watching.